You see a foundation construction, and this lesson is the start of the second portion of the course. We see dealing with the building construction. In the first portion, we discuss heavy construction involving earth moving, hauling, pavement, all of that for heavy infrastructure construction. Now we talk about the building construction. And the first lesson is foundation construction. And we have three learning objectives. First, we want to explain the pipe driving method and explain the hazards of deep excavation and method for protecting excavation and workers working in the open pit when we excavate the material out. And we choose and determine the dewatering system for construction. And as you can see, with that learning objective implies the major issue that we deal in foundation construction for this class is the pipe driving, protection for deep excavation, and dewatering during the deep excavation. And with that one, let's go to the first lesson video. We discuss pipe driving and some excavation protections. So as you can see, the deep foundation components include several structure. The first, as you can see, the pipe in the deep foundation, and then we have the load-bearing diaphragm work, so that to protect not only the water, the pressure from the adjacent soil or adjacent building, and it also resists the water from the soil get into the pit, so that the for the new building, for example, that can be a basement, etc. So with that, we need to work on the piling. That's the first thing, and then we need to excavate. And when we excavate, how to protect the excavations and the workers, and how to dewater, because there is water table under the foundation that you can see here. So those are the major issues that we have. So let's talk the first is how to install the pipe underneath the foundation. Basically, if you can see this one base have a one time of the pipe driving method. You see a vibrator, and that pipe drive into the soil, and this is another type that can drill the pipe. And let me show the quick video of that one before we move on to classify different equipment used for pipe. See that one drilling video for and this is a vibrator to put the pipe down to the ground. So with that one, as you can see, there are several methods that can be done with pipe driving, and it can be classified in three major types. And that first is the impact hammers, and in impact hammers it can have single acting, double acting, and diesel hammer. And then we have vibratory driver, something that I show you in the video previously, and then the jacking driver. So those are the major way to drive the pipe into the soil for the deep foundation. So what's the difference between the double acting and single acting? And you can see in here, so normally the impact hammer can be powered by the air compressor, something we learned in a previous lesson, air compressor, or it can be by hydraulics, or it can be by the diesel hammer. So that many ways that we can do. One single acting, what does that mean? And you can see the and how that different from the double acting. You see the steam. So in this case, the water steam is only on one side, the inside of the cap of the piston. So we want to lift up the hammer, go up to the top, then it gives steam to lift up. And when it go to the top, the air on the top here is short, release the air, and then the hammer will be free fall, and that free fall create a gravitational energy, and that potential energy will drive the pipe going down. That is single acting. Double acting is different, as you can see the compressor or air or steam. It act at both sides of the piston, so that will improve the cycle. So it can the blow it can be more per minute compared to the single acting. So it have flip up and then exhaust the air, it going down, and then do that with the steam at both sides of the piston. So it increase the number of blow per minute for this double acting. And then the last one within the impact hammers, that is the diesel hammer. So that diesel hammer have pre-fall with the diesel power by diesel, and that will drive the pipe going down. So that is the impact hammer, and that will be noisy with this method because, as you can see, have an impact. In the urban areas, people tend to use vibratory drivers, something that you see in here in urban of the adjacent building. If we use the impact hammer, it will be noise, create more vibration. It may affect the adjacent building and the neighbor. So that's why in here in Tampa they use vibratory hammer, and that vibratory driver in here they have a rotating eccentric masses, and you can see that one is that here, that one here, and then we have a suppressor, that one, and of course the host, you have the host in there. So that created by the vibration, and it will drive the piling down. And then the last one is check-in driver is more quiet, will hydraulic press with the weight, counterweight, and will drive the pipe down. So those are the typical method of driving the pipe onto the soil for the deep foundation. And when you finish driving the pipe, the next is we excavate. Then when the excavate, the pipe already go down here, and this is our one to excavate to build this new building, as you can see there. And when with that, we need to maintain the watertight floor slab and walls so that the water will not come from the any of aquifer A, B, C in here to the new buildings, and that create a challenge. And how we can do that? We need to face several hazards with the deep excavation, as you can see there. When we do the open dig, as I show here, to finish the underground substructure of the new building. What other hazards can be anticipated during this excavation? The first problems, as you can see, the groundwater infiltration, because if we don't have a waterproof between the soil surrounding and the new open cut excavation area, the water will infiltrate. It can affect impede the work of construction. We cannot work in this open cut with the water get in. So that the first problems hazard it can be in. The second problem is the collapse of vertical walls. If we have the segmental or diaphragm, and with the shear force, as you can see there, it can make the wall collapse. So that is the second problem. It creates a hazard for deep excavation. The third problem area is the boiling of excavation floor. As you can see here, the water pressure from the beneath, it can be go to the heave of the excavation, and that will create a hazard during the construction. And the last problem, it can be the settlement of the structure. As you can see, when we excavate with the open, then create many other pressure go to the diaphragm, and that make the wall, it will be movement. When the wall movement, the settlement, not only the structure of the new building, it can be the adjacent building also compromise with the settlement, as you can see here. So the ground settlement going down, diaphragm, the wall, new wall for the new building, it will be displacement, and then that will create the building adjacent to that, the old building, the current building can be create a differential settlements as well. So those are the challenges. That's why during the construction, people have to monitor the surrounding buildings to see how it impact the new construction to the adjacent building, cracking, settlement, things like that. So with that, not only the safety of excavation, the worker itself also have to be protected, and that what OSHA come into place. OSHA stands for Occupational Safety and Health Administration. So from that, OSHA create the regulation requirement to protecting the excavation and workers, and it different from the first lesson that when we study soil and rock classification, and that in your geotech one for OSHA to when we talk about excavation, they classify, and that is table 10.1 in your chapter 10 of the textbook. They classify the rock and soil into 4 different types. First is stable rock, as its name implies, and the second is type A. So it defined by the range of unconstrained, unconfined compressive strength of the soils, and then type B, and then type C. So those are the 4 types that OSHA classify when they determine what type of method, shoring, sloping, etc. when you do the excavation. So with that one, go down to the excavation, and when we have the excavation, as you can see there, the in the node we have certain method to protect excavation and workers. First, we can be sloping or benching of the size of excavation. If it not enough, then we can have to shoring, and then the last one is placing the shield between the workers and the size of excavation, so that when the excavation is collapse, because they are shield, worker will not be affected. So those are the steps need to be required so that we can protect both excavation and workers based on OSHA requirement. So with that one here, if you go to OSHA Occupational Safety and Health Administration, and for standard 929, and if you go to standard number 1926, and we have to go to subpart P. So basically we'll discuss about the excavation that you can see here, subpart B. So the one that table 10.1 that we just showed you, and in the textbook it get it from appendix A when they classify the soils, and then we go to part B. We have the sloping and benching, and that is the table 10.2 in our in the textbook. Okay, so that what OSHA, and then of course you have the shoring with the timber, aluminum hydraulic shoring, alternative to, so all of that you can have. And then we have the decision making, which method we use, and how that involves, so that we go to the subpart P appendix F. We have a decision flowchart to make a decision which method, which option we use, and whether it involves even the registered professional engineer to design for the excavation, as you can see there. So that is the today about the OSHA built on subpart P, standard number 1926 of the OSHA, as you can see there. So let's go back to here, so that for method of soil and rock excavation, and then we are talking about that in appendix B with what is the allowable slope for excavation size given different type of soils or rock, if it's stable rock, and if we excavation less than 20 feet or 6.1 meter. Then the allowable slope for horizontal vertical, that is vertical. It can be vertical for stable rock if it's less than 20 feet. If it type A, then it 3/4 one, so horizontal 3/4 one, so about 53 degree. And they side note in here, if it's short term, if we excavate 24 hours or less, and the excavation depth is 20 feet or less, then we can make it a steeper, and that is one half horizontal and one vertical, 63 degrees for type A only. For type B, 45 degrees, and type C, one and a half, and 34 degrees. And again, this apply for the excavation that less than 20 feet. If it's more than 20 feet, we need to have a registered professional engineer to design for the excavation. And with that, I make easy to visualize this requirement. If it's less than 20 feet, then if it's stable rock, then you can do it vertical, 90 degree. If it's type A and excavation is a little bit longer term, more than 24 hours, and the excavation less than 20 feet, then horizontal 3/4 one. If type B, then 1/1, and type C, it half, 1.5 and 1. It should be 1.5 here, 1.5 and 1. And for the short term, as you can see, and have to be less than 12 feet, then we can steeper for type A, half and 1 in there. Again, type C should be 1.5 and 1, not half and 1. So with that one, we apply this concept in the problem 1, and then we will do what happened if the excavation more than 20 feet or more. What kind of shortening system we want, how we provide the seal to protect the worker from the excavation, the size of the excavation, and that will be in the next lesson video. Before we go that, we go back to the note that we talked about the driving, and you can see estimate the load capacity for the pipe is a challenge, and the best way to do that is the in place. To determine the in place capacity is to do the load stat on site. When you already tried the pipe on, we do the load stat and determine the pipe load capacity, and that described very well in the textbook. And then this is the equation from the textbook. Just make an estimate the pipe load capacity with the power hammer we have, and that is the R for the safe load, and S then for the average penetration per blow, and elastic blow in inch, energy of the hammer, so that foot-pounds, we learned that, coefficient of restitution, and that depends on the weight, the pipe weight. We have different factor, and then the weight of the hammer ram, and WP, the weight of pipe, including upper tenons. And this have an example in the book. I encourage you to take a look and work on this, that example, to understand the capacity of the pipe. And again, this is an estimate to better determine the pipe load capacity. We need to do the in place on-site load test.